Last week in lab, you guys performed thin layer chromatography where you eluted a mixture of compounds onto this TLC plate, which was a plastic sheet that has just a very thin film of silica on the top. And so what you guys saw was when you put the TLC plate into your eluent chamber, the solvent rose up from the bottom, and as it wicked its way up the plate, it separated your two compounds into spots. This week, we're going to modify this technique basically, and we are going to run column chromatography. So column chromatography uses the same stationary phase silica gel, which we have in bottles for you. And instead of putting it as a thin layer onto a sheet, what we're going to do is fill up this column, which is basically a burette without markings. So we are going to fill up this column about 1/2 to 3/4 full with silica gel, and we're going to load our compound mixture from the top, so it's sitting right on top of the silica gel. As we run eluent down through the column, we're going to separate those compounds, hopefully. But the thing to keep in mind is that this is going to happen in the opposite direction as the separation on your TLC plate. So in the TLC plate, your least polar compound was the one that was on top of the plate because your solvent was pushing it up. With a column, your least polar compound is still going to be the first one to come off the column, but because it's running down, your least polar one is going to come off first, followed by your next polar and your next polar. So what I'm going to show you today is I'm going to do the practice column just for time's sake for you in the lab. And I'm going to bring you through the practice questions before you're ready to actually do the experiment. So make sure that you grab your lab manual and you're looking at it so that you can fill in those questions as I go along. Okay, so in order to pack the stationary phase, the silica gel, into our chromatography column, we are going to need 3 different things. First off, we need a piece of cotton. We are then going to need a little bit of sand. This is very pure sand. It's been washed of all of its impurities. And then, of course, you need your silica gel, which we're going to make a slurry of inside the eluent that we're going to be using. So the first thing that you have to do is basically use the cotton to plug the hole in the stopcock of your chromatography column. So if I take this out, I really zoom in, the bottom of this chromatography column doesn't have anything to stop solids from going through the hole in the stopcock. And so if I get this adjusted right, you'll be able to see that there is, that's not going to work. There is a hole in the stopcock right here. So when the stopcock is open, that hole is wide enough for all of the silica gel that we're going to put in the column to flow right through it. So what we're going to do is take a little tiny piece of cotton. This is really not much cotton at all. We're really just trying to block that hole a little bit. We're going to put it into the column. And to get it to go all the way down, the best thing that you can really do is just grab a thermometer and very gently just kind of ease it into the column. And you're going to get that all the way down to the very, very bottom. So what you're going to do to get that to go right to the very bottom is go ahead and put it back onto your clamp. Make sure that your column is nice and straight up and down. And you are going to pour a little bit of the solvent into the column so that you get that cotton plug nice and saturated, and then when you drain some of the solvent, it's going to plug the bottom quite well. And if it doesn't quite go to the bottom, you can go ahead and just stuff it down there a little bit. You don't want to pack it too tightly. If it's too tight, it's going to be a problem for getting your solvent to flow through it. So you just want to kind of gently cover that hole. And now, if you look really closely, I'm going to take this back off for a second. If you look really closely at the bottom of this column, the column is very, very straight until it gets down to about here, and then it starts to curve over. We cannot have the diameter of the silica gel increase or decrease as you're running your compound down, because that's going to affect your separation. And so what we're going to do is put a little bit of that sand into the column until it's at the point where the column goes straight again. So I'm going to do that just by tapping some of it in from a test tube. And let's see. I'm just going to flow some down. And you can see I got it all over the side of the test tube, and that's really yucky. Okay, so I'm going to take a pasture pipette, just put a little tip on it, and I'm going to dribble some of this solvent down the sides just to rinse the sand all the way down from the column, because it's right now all over the sides of my column. And I don't really want that there, I just want it all on the bottom. The other thing that this is good for is when you pour the silica gel in, you don't really want to disrupt the sand on the bottom, and when it's dry, it's really easy to do that, and then you end up with kind of a yucky mixture at the bottom of the column that's a mixture of silica and sand instead of nice pure silica. I've got my little plug down at the bottom of cotton, and now my sand is sitting on top of it, so when my silica comes in, it's going to just be on the part that goes straight up and down. But if you look, my sand is really not all that flat, and I do want to fix that. I want my silica pad to be nice and flat, both at the bottom and the top. And the way that you can fix that is just kind of gently tap. The other thing that's good about this is it gets rid of your air bubbles. And so if you just kind of gently tap, you get rid of most of those air bubbles, and you flatten out the sand bed so that the silica is going to be nice and even. So now what I have to do is load the silica onto the column, and we do a technique called wet packing. It's the easiest way to get the silica in there nice and even and prevent air bubbles from being in the silica. Any kind of air bubbles, any unevenness at the top of the silica is going to lead to poor separation of your compounds. So instead of pouring my silica gel straight in to the column while it's dry, instead I'm going to add some of the solvent to it. I'm going to mix it up into a nice mixture of slurry, and I'm going to pour it in the top as fast as I can. So what we are going to do is read your lab really quick to see what volume it tells us to use. So I've got my copy of the lab manual right here. And so this tells you that you are going to add 20 milliliters of your eluent mixture, which is 1:1 acetone ethanol. So I'm going to add 20 milliliters of that to my silica. Let me just pour it off real quick. This does not have to be exact at all. Okay, so 20 milliliters of my eluent is in there, and now I'm gonna just pour it in, and it kind of mixes, but you want to make sure that the silica really stays suspended, and silica is really, really dense. So you're just gonna stir it with a stirring rod, and you're gonna continue doing that until you have poured it into the column. So the way that we usually have you guys think about this is it is slurry, 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 dump. Because my hands are a little shaky today, I'm going to put a funnel on top of it. And so here we go. Hopefully this works in one shot, because I kind of only have one shot to do this. So I am going to slurry, slurry, slurry. Keep on stirring. You can't see a thing. Slurry, 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 slurry. Keep it all mixed up. And then literally just pour it right in. And that is now in there, and what's going to happen is the silica is going to start to settle down. While it is settling down, what you want to do is kind of tap, and you should remove your funnel. You just want to tap it a little bit just to make sure that the silica goes in nice and evenly. You can flick it with your finger, or you can tap it a little bit. You don't have to do it constantly, but it is a good idea because this is also dislodging any air bubbles that are in it. So I am just going to speed this up until it's finished settling on the film, just so that you're not sitting here being bored by it, and then I will show you the next step. Okay, while this is still settling, one thing I want to point out is you are not going to get absolutely all of the silica gel out of your beaker. Some of it is always going to adhere to the glass, but If you have more than just a light coating on your beaker, that means you didn't slurry it all that well right before you poured it in. That's okay. What you can do is, at this point, you can drain some of your solvent. Let's see if I can get this out just a little bit more. No. I'm going to drain some of my solvent from the column back into the beaker. I'm just going to let some of it out the stopcock. But I'm going to make sure that when I do this, I do not let the silica come into contact with air. I'm just going to let it drip, and it is kind of slow, unfortunately. Just so that I can use that solvent mixture again to rinse the column. And the other thing I noticed was my column is not being held tightly, so I'm just going to really clamp it well. That's much more stable, okay. So I'm just letting some of it drip back in, and when I have a fair amount of it, I can go ahead and use that to kind of try and get more of my silica up onto the column. The other thing is at the very, very top here, there is some silica that just kind of stuck to the sidewalls. I do want to rinse that down if I can. I don't need to wait for all of it to go down, but I do want to get enough of it that I can rinse most of the silica back up into the column. So I'm just going to let it drip, drip, drip. I've only got about 3 mils right now. So again, I'm going to speed this up for you guys. So I've got enough to demonstrate here. So now what I'm going to do is I'm just going to use that to try and rinse that silica off the sidewalls. And because I had silica in my beaker, that didn't work too well. So I will take some fresh eluent and drain it and rinse the sidewalls before I start running the actual column. So now I'm just going to take a clean pipette and I'm just going to gently kind of coat the walls with some of that eluent, and that's going to rinse the silica that's hanging up on the side down in. So now all that's left to do at this point is just wait for it to allow the solvent to drip down to the very top of the silica gel. Again, I do not want my solvent level to actually expose the silica to air. I'm going to stop it just shy of the top of the silica bed. And so I will speed this up and talk to you again when it gets down to that point. So I zoomed you in so you can see just how close I'm going to get to the silica column before I actually stop it. It's kind of a game that you have to play at this point between making sure you don't get the top of the silica exposed to air, but also making sure you have as little solvent as possible above it, because the next thing that we are going to do is load our compound onto the column. And the theory of column chromatography is that almost there, it's just above, okay. The theory of column chromatography is when you load your compound onto the column, which I've got my compound right here, the height of the column that I load, not the height of the column, the height of the compound when it goes onto the silica is going to be the height of the bands that come down the silica. If I have a whole bunch of solvent on top of here and then I load that compound into that solvent, it's going to get diluted and essentially widen the band of the compound that I'm putting onto the silica. So I want to have it very, very, very close. Now what I'm going to do is take some of this dye mixture and I'm going to load it onto the column using a pasteur pipette. And I want to do that as gently as possible because the top of this silica gel is very, very, very easy to disturb. And I want to keep that nice and flat. So just the force of the compound coming down the walls of the column and then hitting that silica can disrupt that bed, and I don't want that to happen. So I'm going to get some of this dye mixture out and show you how to load it onto the column. So your lab manual says that you are going to load, how much is it? 0.25 milliliters of this compound. So what I'm going to do is take some of my dye mixture and I'm going to measure it using this syringe. I'm going to measure 0.25 mils of it into a test tube so that I can use it to load onto the column very gently. So just measure that out. So that is how much on the compound mixture I'm going to add. So this is a mixture of 3 dyes. They're actually acid-base indicators. And so because they're acid-base indicators, you're going to see they're not necessarily the color that the name says they are. Methylene blue may not be blue. Methyl red may not be red, because they are only that color at a specific pH range. So here's what we're going to do. We're going to draw this dye mixture up into a pasteur pipette. And it should be a clean, dry pipette. And now I'm going to, as gently as possible, let this run down the side of the column without putting any pressure on it so that it doesn't disturb the silica gel. And so it's just barely dribbling out. This is a very slow process. I do have it fairly low so that it doesn't kind of speed up due to gravity. I've got this fairly low in the column. My famous mistake is I accidentally break the pipette in the column. That's always fun. I'm just doing it nice and gently. And you're going to see it is going to sit above the silica when it is all loaded on. And let's see if I do a good job at this. I don't run very many columns. I'm not an organic chemist. It's just not something that I do. So this has actually been the one video that I've been absolutely terrified to film, because it's also one of those types of videos that I can't stop in the middle and start over. Once you start running a column, you can't stop. So if I screw up, I have to start all over again. This is my first take, so we'll see how it goes. Okay, so I have that loaded on top of the silica. Now I'll zoom you back in now. Whoops, sorry. Again, one take means I don't have a lot of opportunity to stop and readjust. Come on, zoom in. I think this time I will stop just so that I can get this zoomed in. Come on. I had you zoomed in perfectly before. Do it again. Hello, there we go. So you can see the dye is sitting on top of the silica, and that's how you want it when you start out. But what I have to do in order to get these compounds to move down the column and separate is I have to add solvent to the top of the column and start flowing it through. If I start doing that right now while the dye is sitting on top of the silica, all it's going to do is dilute that dye into however much eluent I add. So the first thing that we have to do is lower that dye so that it's down on the silica so that it adsorbs onto the surface of the silica particles. So I am going to open the stopcock again, and I'm going to allow some of the eluent to go through until I'm, again, just touching the top of the silica with my, my meniscus. So I'm opening it right now. You can't see it, it's off camera, but here we go. And you'll see that the dye particles start to move down and turn the top of the silica a different color. So it's dripping now. Again, you just want to make sure that the top of your silica doesn't come into contact with air. And now it is coming into contact with air, and that's not good. Or it's just about to. So now what we have to do is make sure that as we add the eluent to flow through the column, we need to make sure that we're not disrupting the top of that silica again. And so what we're going to do, oh, I just stepped in front, I'm sorry. What we're going to do is add some more sand on top of the silica bed so that we don't have to worry about that. So I do have another little test tube of sand, and I'm going to tap it in oh so gently on the very top of the column so that I have a little protective layer of sand. So I'm literally just tapping and adding this sand as slowly as I can until I've got about a centimeter of sand sitting on the top of the silica. And of course it's not going in evenly, so I'm going to have to hit it from all sides. There we go. There. So now I've got about a centimeter sitting on top of that. I don't really want to tap the column too much at this point. What's going to happen now is I'm ready to start running my column, and so what I'm going to do is I'm going to take my eluent, and it can be the same stuff that just came out of the column, that is fine. And I'm going to fill up the column with my eluent. So my dye is safely loaded onto the silica. It should have all absorbed onto the silica. And I'm going to start out by just doing a little bit of it. And again, I'm going to just kind of gently flow it around. You do want to make sure that you don't disrupt the sand so much that you free up a portion of that top pad of silica. And then once you've got a good amount of solvent in there, you can go ahead and continue a little bit more forcefully. Now, instead of dripping my eluent back into the beaker, the stuff that's coming out of the column, I'm going to switch to test tubes so that I'm not contaminating my nice pure eluent. So I have a test tube underneath here that I'm going to start collecting my stuff in. And as I said, this is the part where now I've started my column. I really should not be stopping, and so I'm going to be continuously kind of collecting fractions, and at the same time I'm going to keep an eye on the top of the silica to make sure that I have enough solvent. And once I've done this a few times, I'm going to zoom in so that you can see what's going on at the silica. I think what I'm going to do now is I've got enough in there, I can switch to just very gently pouring it. I'm going to fill it right up. So now I've got that topped off. I want to zoom in so that you can see what's going on with the dyes that are in the compound. So you can see they've already separated out. I've got a green band, which is one of the dyes, a yellow band, which is the second dye, and then a blue band sitting on top, which is the third dye. So I'm going to let this continue to drip, and what I'm going to try to do is capture the green band in one test tube and the yellow band in a different test tube. And while I'm doing this, I am going to talk you through some of the questions that are on page 70. So if you go to page 70 of your manual, that is where you have P3 at the top and then a chart with 5 organic compounds down at the bottom. The first thing that you're supposed to do is rank the 3 dyes, which are the 3 dyes that are in my dye mixture: methyl red, methylene blue, and bromocresol green. You're supposed to rank those in terms of their polarity. And so if you think about the intermolecular forces that are present due to the functional groups that are on all 3 of those molecules, I think you can identify pretty quickly. You've got a carboxylic acid group on methyl red. You have actually an ionic portion where you've got a nitrogen with a positive charge and a chloride with a minus charge on the methylene blue. And your bromocresol green, it's actually got a fair amount of organic stuff. It's much larger in terms of its organic components. And it doesn't have that hydrogen bonding capability that the carboxylic acid has, nor does it have an ionic component. So with those 3 functionalities in the compounds, you should be able to accurately rank those in terms of polarity at this point. So I am not going to actually answer P4, P5, but I will remind you that this does work exactly the same way as TLC. So what's going on is my dye compounds, when I loaded them onto the silica, they adhered to the silica particles through intermolecular forces. And so remember, the stronger the intermolecular forces, the harder it's going to be for the eluent to disrupt those compounds off of the silica gel. So that should lead you to the conclusion, just like in the TLC lab, that the least polar compounds are going to be the easier ones to take off because they are going to have the weaker set of intermolecular forces between themselves and the silica gel. So whichever of those is least polar should be the one that comes off first. It doesn't matter what eluent system I use, the least polar compound is always going to be the first one that comes off the silica gel. But what I can do, if I want them to come off faster, is switch to a more polar solvent, because if my eluent is more polar, and I just switched to a different test tube, just so you know. Oh, I should zoom out because you can't see. So now you can see at this point, my green is all the way down here. And so I'm almost at the point where the green dye is coming off. And I'm just going to keep on going. I still have plenty of eluent in here. I'm way up here with my eluent level, so I am going to keep on going. So as I was saying, if you want to make all 3 of these bands start moving faster, they're still going to come off in the same order. But if I want them to come off faster than they are right now, what I'm going to do is make my eluent more polar. And so this was the idea of when you were tweaking your eluent for the TLC lab to give you an RF value of 0.2. I'm sorry, of 0.8. You wanted it to go through faster. You changed your solvent so that you had more ethyl acetate in it, which made it more polar, which made everything move up quicker. So now my green is in the sand at this point, and it should start coming through the cotton and down into my test tube really quickly here. So I am just going to switch. Oh no, it has already started coming off. It's difficult to tell, it's a very faint color, but if I kind of do this, I do have a green color coming through into my test tube. So this is my first dye coming out into my test tube. It's a little greenish colored compared to this was just pure eluent in this other test tube over here. So that is coming out, and once I think that that is all off, I am going to switch to a different test tube, and we're going to keep going and see if we can get the yellow one to come off into a new test tube as well. I think that's pretty much gone, so now I'm just going to do this. So that was test tube number 2. This is test tube number 3. We're going to see if anything comes off of it. Actually, I did still have a little bit of, oh geez. No, this is right. This is right. Apparently my test tube was dirty, and so it turned that last little bit of green dye. There's a pH difference going on in the test tube, so it turned it blue. Yay! You can see now that yellow dye has moved about halfway down the column, so it's starting to get there. It will eventually, as we run more and more and more of this eluent through, continue to work its way down. As will the blue. If we run enough through, eventually that should come off of the silica as well, but we're not actually going to go that far because it does take a bunch of this eluent to get that to happen. And so right now, I am actually between the two different colored bands. The first band has completely come out of the column and it's sitting in the test tubes now. And so I'm collecting just nice, clear, colorless eluents again. And I'm going to continue doing that until the yellow comes off. So while I'm waiting for that to happen, I think you guys should be able to fill out part P7 fairly well. Just remember, the compounds on a chromatography column or a TLC plate, they are always going to come off the same way. The least polar one is always going to come off first, and the last one to come off is always going to be the most polar one. So on this column, the most polar one is the one at the top. The least polar one was the green one that came off earlier. On a TLC plate, the least polar one was the one that went to the highest on the plate. The least polar one was the one that moved the least. So now I'm going to skip over to page 71, and there is a stop point. I am going to go ahead and talk you through that right now, just so that your instructors don't have to do that. And you can move straight down to the individual experiment at the bottom. So I already talked about what the purpose is of the cotton plug that I put right into the bottom of the column. So if you missed that, go ahead and find it where I talked about it earlier. What is the purpose of the sand at the top? Again, I already talked about that. What is the significance of the solvent chosen to prepare and run your column? So the significance of the solvent, just like TLC, you want something that is polar enough to allow your compounds to actually move through the stationary phase, through the silica gel, but you want it to be not so polar that everything moves in one single fraction. When you are trying to convert from thin layer chromatography to column chromatography, you typically end up using a solvent system in column chromatography that is a lot less polar than your TLC column. And the reason for that, or your TLC plate, the reason for that is the amount of compound that you have on a chromatography column versus a TLC plate is a lot higher. You've got a lot more compound relative to silica in your column than you do on your TLC plate. So because of that, you end up needing to have a lot less polarity in your eluent so that it's, you get a better separation that way. You don't disrupt your intermolecular forces as quickly when you have a less polar eluent system, and that's what you need for column chromatography. So you always start with a, if you know in TLC what your eluent mixture is going to be, you typically will start running your column chromatography with that mixture, and you'll find that it is too polar, and so you end up having to make it a lot less polar by adding less of your polar compound. D4 talks about adsorption versus absorption. So remember, adsorption is a compound sticking to the outside of the silica just through those intermolecular forces between the compound and the silica particles. Absorption would be the compounds actually going inside the silica gel. And both TLC and column chromatography rely on adsorption, where it's sitting on top of the silica. It's just bound to it through those intermolecular forces. So streaking on overloaded silica TLC plates, why does that occur? Well, if you think about a silica gel particle, if you put too much of your compound onto the TLC plate, you end up on that one spot where you put your compound, you have more compound than silica, and so you occupy all of those sites where your compound can adsorb onto the silica gel, and so there's going to be some compound that is not adsorbed, not stuck onto the silica. Then you start to elute your plate. Those compounds that have not, the molecules that are not stuck to the silica, those just move up with your eluent because they're not being held back by the silica at all. So they move up a little bit, and then some of them get stuck to kind of the next area of silica. And then if you really overload your plate, maybe you have even more than that. So you still have some that's moved up a little bit that's not adsorbed onto your silica gel. So it moves up a little bit more, and then those adsorb, and then you move up more into more adsorb until finally you got it all adsorbed onto the silica. But instead of having it in one nice little compact spot, now your compounds have moved into this kind of big band, starting at the bottom where you originally spotted it, moving up. So then when you elute that, it's going to elute in that same kind of band pattern as you go up the plate. That is why you end up with a streaky silica gel plate. It's just because you added more compound than could be absorbed by the silica. So now we are almost at the point where the yellow is coming off. I am just going to go ahead and switch tubes, and we'll try to get all of that yellow dye in one tube. We'll see if that works. And so now it asks, could we monitor a column's progress using UV? And so that was one thing that you guys did in the TLC lab. You took your plate after it had been eluted and you shined it with a UV light. And that is what allowed you to visualize your spots. It would be great if we could do that on our column. So at any point in time, we could kind of shine a UV light on it and see where our spots are, or our bands in the case of column chromatography. Unfortunately, we can't do that, and it's the same reason that you can sit inside your house or in your car with the sun shooting through the window and not get a sunburn, because glass blocks UV light, and so the glass of the silica gel column doesn't allow the UV light to get through it, so it can't interact with your compound, so it can't fluoresce. So while that would be great, we can't do that. It is possible to purchase chromatography columns. Sorry, my motion sensor just went off. Okay, my motion sensor doesn't realize that I'm still in the room, so hold on one second. Ugh. I'm in a bad spot, so I am actually going to stop this for a second. Hi, still here. Thank you. Oh, those are fun. You can actually purchase silica gel or chromatography columns that instead of being made of glass are made of quartz, because quartz does allow UV light to pass through it, but those are prohibitively expensive, and so pretty much everybody, especially in organic chemistry, will use just regular glass columns. But what you can do is every time you take a fraction, you can take some of that with a capillary tube and you can spot it onto a TLC plate, and you can see if your compound is in there, because you would see a spot when you take this plate and put it underneath your UV light. That is typically how we monitor column chromatography when we're dealing with compounds that don't have a visual color like these dyes do. So we're just going to keep on going. It is almost there. It has not come off yet. I'm really sure it's pretty close though. So we'll switch one more time, and I'm just going to combine that with that prior test tube. So this is what column chromatography is. It's just letting things drip endlessly. And again, if you can't see your compounds because they're colorless when they go through the column, you're just going to collect equal fractions. And so in lab, what we're going to tell you to do is collect them in 2 milliliter fractions. Now, obviously, our test tubes don't have graduations on them. You don't know what 2 milliliters is in these tubes. So what I would recommend you do, take your graduated cylinder for the first fraction, collect it in here until you're at 2 milliliters, then pour that into a test tube. For the rest of them, collect them in the same size test tube and then just match the height of that first one. We're looking for about 2 milliliters, not exactly 2 milliliters, so that would be fine. And just every time you collect a fraction, you're going to make a spot onto a TLC plate to see when your compound starts to come off. And so if your compounds are not in that particular fraction, you won't see anything when you shine it under UV light. When your compounds start to come through the column, they do show up, and they do show up very well. I ran this many times over the summer trying to get a better solvent mixture, and I can tell you that they do come off very well. And you see a nice dark spot for your compounds. They do come off in multiple fractions, and it works very well. Unfortunately, it's not the most exciting thing in the world, and you know what? I just realized I ran out of solvent on the top. That's not good. Hopefully, yeah, it didn't go all the way. So it's still, my silica is still wet. It's just I ran down into the sand. So add a little bit more. And I don't know if you can tell, I will shine my, I'll put my plate up behind it again so you can tell. This is not coming out white anymore. My solvent, or my second dye compound is now coming out of that tube. And so you can see the difference in color between just my eluent, which is this one over here, and the one I'm holding underneath the column is now kind of yellowish. So that is definitely my second compound coming off. And you can tell while that's coming off, look at where my third dye is. It's still way up here, stuck to the silica. I could make that come off by tweaking my solvent mix, and that is one of the questions. I'm going to leave that up to you to answer back on page 70. Although we didn't collect the methylene blue dye, which is the one up here, what might we have to do in order to collect it, in order to get it to actually come off of the silica? What would we do to our eluent to make that guy move down? So that is a question that I will leave up to you. But you can see at this point what I have done. These are the fractions that I collected. I am just going to hold them up for you right here. I'm going to grab a white sheet of paper. So these are the columns, or the fractions that I collected, and I'm trying to figure out how I can do this. Okay. So this first one was just eluent. It was before I started getting my actual compound to come off, and then I collected these two fractions next, which were actually that second dye to come off. So it started off looking kind of yellow and then turned blue. And then after that band came off, I had another fraction where there was none of my compounds. So I had actually really good separation. I had a fair amount of solvent in between that first fraction, and then here's the kind of first portion of my second fraction. So I have now been filming for over an hour. I am going to cut it off here. You guys should be able to answer the questions that go through page 71 that will bring you to actually running your experiment. And so go ahead and have fun in lab this week. Good luck. Goodbye.